Okay.
Fiza, can you hear us? Hello, Fiza.
Ya, doktor, boleh.
Boleh. What can you see on the screen ya?
Hitam, tak ada apa-apa.
Tak ada apa-apa. Okay, so
Kena share.
okay, let's go back to Sam. Ada?
Ada?
Ada apa?
Ada poster seminar.
Okay, good. Alhamdulillah. Okay, alright. So Fiza, you have about 15 minutes nanti ya. Lepas tu
Okay.
soalan yang dua soalan yang Dr. Noli akan tanya ya.
Okay, doktor.
Okay, right. So kita orang gonna mute you sekarang ya. When the time comes nanti. Okay. Okay, good. You get the hang on. Buka jap.
Dia akan
keluar.
Dia akan keluar lah.
Nak unmute you ya. Hello Abdullah. Unmute Abdullah.
Unmute.
Hello, assalamu alaikum.
Waalaikumsalam. All right. So we are waiting for one more ya.
Okay.
Okay. All right. Good. So you will be taking care of the slides from your end, right, Abdullah?
Yes, yes,
Okay.
yes, Prof. I already sent to the Dr. Noreen, and I think, and also I prepare everything.
Abdullah, can you give your email because I cannot find your email. I'll try to search for it. Or can you resend it back?
Resend it to the email Dr. Noreen.
Yeah, norli@um.
When did you send?
Mine.
Yes, sir. Yesterday.
But I cannot find it.
Okay. I'm afraid we don't have yours. So can you upload from your end?
Okay. You want the slides, Prof?
Yes.
Okay. Well, I will upload it now.
Okay. All right. Great. So we are waiting for one more. Yeah.
Okay, Prof.
Okay. So we've got about 5 minutes and.
Itulah, but kalau tu dia Fiza kata I share slide sendiri tau. Okay.
Okay, Prof. I send it. Please check. I cannot hear you. I cannot hear you.
Okay, looks like it there we don't have it. So I'm afraid you have to upload from your side.
It's already, I send it now.
I know, but our internet is a bit slow here.
Okay.
So you have to upload, but
He will present.
he will upload from his
share
end.
lah.
Yeah, you will upload from your end. Yeah, you know at the bottom of it. Are you familiar with it?
Which one, Prof?
Okay, if you take your cursor down, and then there's a say share screen.
Yes, of course, yes.
So
Yes,
so
I
then,
know.
then
Share
you
screen.
can share your slides there. Yes.
Yeah,
okay.
yeah. Okay, Prof.
Okay, so we're just waiting one more person.
Okay, Prof.
Is it possible kalau kita start tapi
Okay.
Dia masuk later lah kot?
Yeah. Nanti kita tengok. Yeah. Okay. We have about 2 more minutes, so we will start 12 o'clock sharp. Yeah.
Dan ni sekarang masuk lagi. Ada WhatsApp.
Dia tak responding.
Kita semua mute, sekarang unmute-kan semua kot.
Mereka Mbak Itam, boleh share nombor Faris tak? Sebab dia tak masuk-masuk lagi mereka dah nak start dulu.
Cuma nak ask to unmute kot.
Faris. Research doktor tu dah tumbuh lah.
Tu masuk. Okay, Abdullah. So start in a few minutes. Fiza, we will start in 1 minute. Yeah.
Okay, Prof.
Okay, bye.
Okay.
Hafiz nanti mute-kan orang bila I cakap nanti.
Beginning of a PhD student on the
Tapi tak ada orang masuk. Ada attendees tu berapa? 12 orang.
17.
suitable research objective
Yang macam tu tak
on study according with the time frame. Time
Abdullah mute-kan ni.
sebab dia tak masuk lagi lah. Kita nak start lagi 1 minit.
Tutup Christmas. Very good afternoon, everyone. On behalf of the University Malaya, it gives me great pleasure to each and every one of you, the participants, as well as the speakers to the first postgraduate conference of the Institute Statistics Malaysia. I hope you are well and safe wherever you are. So we hope this session will provide an avenue for us to interact each other, although remotely, but I believe at the end of the session, we will be able to share our work and also exchange ideas on some of the fellow postgraduate students are working on. So before we start this session, I would like to thank the parties that has been helping us to organize this, the Institute of Science Mathematics at the University Malaya and Center for Foundation Studies at the University Malaya. So without further ado, I would like to introduce the first speaker, which is Nur Hafiza. Okay, give me a minute to share with you the slide of the presenters. Yeah, Hafiz is together with me helping him. So Hafiz, can you share the slide of the speakers? Okay, I need to read the title. Okay, just a second. Right. So the first speaker, Nur Hafiza Muslim, is a postgraduate student registered at the University of Malaya. Her title is Imputing Missing Values with Bootstrap Estimation for Circular Variables. So with that, I hand over the floor to Nur Hafiza. Yeah. So give us a minute again for us to share her slide. She will be taking it on her end. Yeah? So Fiza, please open the camera and also we will unmute you.
Okay, Doctor and everyone, thank you.
At the presentation view. Yes. Okay, great.
Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Today I will present about imputing missing values with bootstrap estimation for circular variables. So in most areas, data are obtained using specific instruments which collect the data regularly, and at times readings of the sensor were lost due to the unexpected events or communication error by Yi et al. 2016. So researchers tend to remove all the missing values, thus it will reduce the sample size of the study and leads to the inaccurate and biased analysis by Little and Rubin 2002. So we are interested to impute all the missing values, develop a method to impute the missing values specifically for circular data. So till now, works to address missing values for circular data are somewhat limited. Okay, based on these researchers, based on this literature review, and missing values for linear data, we have Masran et al. 2013, Radi et al. 2015, Safid et al. 2016. Motivation of this study to explore the performance of imputation approach using Bootstrap T for circular variables that has von Mises distribution. Okay, so two methods that will be considered are mean direction and Bootstrap T. So mean direction method is a common method of imputing the missing values using mean. And Bootstrap T, research on imputation the missing values using Bootstrap T method can only be found for linear variables based on this literature review. So it assumed that Bootstrap T method will have an improvement on the biasness of the data for circular variables by Porter et al. 1997. And Bootstrap T method is suggested to have a great potential as it is said to have smaller coverage error by Hall 1986. So most common distribution that we will use for these circular random variables, von Mises distribution. So the equation as in equation 1, we have two parameters of von Mises distribution, mean and kappa, concentration parameter. So in the distribution, we have I naught kappa, which is the modified Bessel function of order 0 and can be defined as in the next equation. So as kappa increase, the distribution of theta approaches the point distribution concentrated in the direction mu. Thus, it will approach a normal distribution with mean mu naught and variance 1 over kappa. And as kappa approach to 0, distribution of theta converges to the uniform distribution. So since kappa, the concentration parameter, cannot be evaluated easily due to the presence of modified Bessel function, we will use the MLE to estimate kappa cap. We will consider two methods as mentioned earlier, mean direction and Bootstrap T, where mean direction is often used and the simplest method. It imputes the missing values using mean obtained from the available data. Bootstrap T, more appropriate and have better accuracy than the previous Bootstrap method, where the previous Bootstrap method, we always use percentile bootstrap, give unsatisfactory result if sampling from skewed distribution by Shenik 2007. This method will not be affected by the skewness, since it will find the appropriate quartile of the Bootstrap T distribution in the procedure of finding the confidence interval. So simulation studies will be carried out to assess the performance of these two methods. This is the simulation process of the first method, mean direction. First step, generate random numbers for von Mises distribution. Second step, missing values, distribute Q missing values in dataset from step 1, followed by the third step, parameter estimate. We have two parameters, mean direction and concentration parameter, as noted respectively, from the available non-missing values. And the last step, imputation. To complete the data set, we will impute the estimated parameter from step 3, then estimate the new parameters. Second method for Bootstrap T, step 1, resampling, simulate M values of theta I from von Mises distribution. Then second step, Bootstrap parameter estimate. We have another 3 steps under this step 2. The first one is estimate mu1 cap and kappa 1 cap from step 1. And calculate, second step, next calculate standard error as 1 cap for mu1 cap as in this equation. Next, calculate the t-value as in the equation t1. And step 3, impute the t-value from step 2, then estimate the new parameters. So these are the informations for the simulation process. We will consider 4 sample size, n equals to 30, 50, 100, and 200 with 4 concentration parameters, 2, 4, 6, and 8. So without loss of generality, the mean direction mu will be assumed as 0. And the simulation process will be repeated to 5,000 times. Each sample will assign with these 6 percentages of missing values: 5%, 10%, 15%, 20%, 30%, and 40%. And the bootstrap replication will be set as 200 by F1 and Tipshirani 1993. So to measure the performance of kappa, these are the indicators. We will use 3 indicators. The first one is mean, kappa cat bar, EB, estimate bias, ERMSE, estimated root mean square error. Results and discussion. So table 1, this is the results for simulation process for n equals to 30. So M1 note as mean direction and M2 note as bootstrap T. So from the table here in blue color, so we can say as the percentage of missing values increase, EB, estimate bias, and ERMSE of M1 are higher than M2. Thus, huge different values of EB and ERMSE between the two methods. So, M2 performs well for all concentration parameter kappa. Next table, we consider for n equals to 100. So M2 consistently gives an estimated kappa, which is close to its true value. So if we consider for all results for M2, the values are close to true value. But when the percentage of missing values increase up to 40%, the new mean are far away from the initial mean. Okay. So as a result, it tends to produce larger values of EB and ERMSE. So these methods are no longer suitable to be implemented when the percentage of missing values are from 40% and above. Okay, so as the percentage of missing values increase, EB and ERMSE by M2 constantly produce smaller values for all kappa. So we go to illustrative examples. Okay, so we will consider the data from meteorology station at Kuala Terengganu. So we will use daily wind direction data in radian recorded at maximum wind speed. So the data were from years of 2013 and 2014 at an altitude 5.2 meter. We consider two sample sets of data during the northeast monsoon. So first set is sample size equals to 31 and another set sample size 151. So prior to the imputation methods, R square, which is determination coefficient values, was applied to both data sets to test the goodness of fit as in this equation. This is to describe the suitability of the von Mises distribution to the wind direction data, and it has been widely used for the goodness of fit test. So table 3 shows the results of R square data, R square values. So since both sets give R square between 0.8 and 1, so we can conclude both data fits well to the von Mises distribution. So next slide is the results of the illustrative examples. So we have two values of kappa cap for the first set, sample size 31, and second set is sample size 151. So table 4 gives the estimated concentration parameter and estimate bias based on imputation method for n equals to 31. So we can see in this table, in chocolate color, M2 gives estimation that is close to the true value and get worse as percentage of missing values increase. And estimate bias EB consistently gives smaller values for M2 compared to M1. So similar results we get for second set of data, second sample set, which is n equals to 151. So estimate bias EB consistently gives smaller values for M2 for both data set compared to M1. So we can conclude M2, that is imputation missing values by bootstrap T method, is the superior method in handling missing values for von Mises distribution. Okay, these are all my references. And this is my appendix. So we get the similar results as n equals to 30 and 100. So I just paste it in the appendix slide. Thank you.
Thank you very much, Hafiza, for the presentation. So once again, for all the participants who have just joined us, I would like to welcome everyone. So the first presenter has already presented her work. So I do welcome questions, comments from the participants. So all you need to do is to type the message in the box there. So we will answer all the questions as well as the comments at the end of all the three presentations. Yeah. Right. So once again, thank you, Hafiza. So we will move on to the next speaker. So Hafiz will share the slide where the next speaker is Abdullah. Yeah.
Yes, yes, above.
Okay. Abdullah Muhammad is a postgraduate student registered at the University Putra, Malaysia. His talk is on the new support vector regression for the identification of high leverage points in high dimensional data. So Abdullah, the floor is yours, and I'm afraid you will have to upload the slides from your end, yeah?
Okay, Prof. This is the PDF. Okay, bro. Just I don't know why I can't open the camera.
Okay.
So can I? Can anyone?
Yeah. Okay. Yes, we can see Abdullah. So please proceed.
Okay. Okay, bro. Okay. Assalamu alaikum and hi everyone. This is Abdullah Muhammad. I am PhD student. My field of study is robust statistics under supervision of Professor Dr. Habshamidi at University Putra, Malaysia. Now I am going to present my research under the title, a new support vector regression for identification of high leverage points in high dimensional data. So this is the content of my presentation. We will start from the introduction and the objectives, methodology, and we will test our method in real data and simulation study and the references. So we'll start in the introduction, the high dimensional data. First, we want to know what is mean of high dimensional data. High dimensional data refer the situation when the number of dependent variables is much greater than the number of the sample size when P is much greater than N. Such a data occurs in an area like information technology, bioinformatics, astronomy, and also in social media and so on. Outliers often exist in high dimensional data and difficult to identify without a proper diagnosis method. It's very critical to detect the outlier since it has high impact of the result of the various statistical analysis and estimations such as the coefficient, fitted values, and the goodness of fit and the variable selection and so on, according to the Hopkins. I will pass this one because I will explain in this plot. Actually, we have several types of the outliers. First, we have vertical outliers and we have high leverage points. And first, we need to know what is the difference between all. So in the first group, as we can see here in this plot, this is the outlier flying in the y direction. This is known as vertical outlier, and this type is very dangerous because it's responsible of the failure of the model. So the second type, it's the high leverage point, which is the outlier in the group 2 and the group 3 flying in the x direction. So we have two types of the high leverage point. We have good leverage point, which is supporting the line of the regression slope, as we can see here. It's just in the same line. And the bad leverage point, which is have the bad effect on the regression slope. So there are many good papers for identification of the high leverage point in the linear regression. On there you can see all these references, Habshan, Rahmatullah, Imon, and so on, all the good papers, and also it's very new. And recently, the Han and Rana and Habshamidi in 2015, and also in 2018, developed approach improve the performance of the epsilon support vector regression for detecting outlier in high dimensional data. They call it fixed parameter support vector regression, which is employ epsilon support vector regression is not very successful to identification of the mild outlier and high leverage points. To remedy this problem, we propose using a new support vector regression to detecting the extreme and mild high leverage point. So the objectives of our research is to develop a new method for support vector regression for identification of high leverage points in high dimensional data, and to show the new proposed method have less masking and swamping effects, and to show that the new proposed method have less computation running time, and this point is very important in big and high dimensional data. And also to show the merit of our proposed method through the simulation study and real high dimensional data. So we're going to explain in the methodology the fixed parameter, the recently method fixed parameter support vector regression. This is fixed parameter, which is employ a E-tube support vector regression, has been suggested in order to evaluate the performance of the standard support vector regression to detecting the outliers. The advantage of the non-separateness of the E-insensitive loss function has been analyzed in the fixed parameter. And the advantage of the non-separateness insensitive loss function has been used the fixed parameter E-tube support vector regression. Hence, detect outlier can be done by using a loss function when epsilon parameter equal to the 0, and this is the formula for the E-tube loss function. And this is the convex optimization problem for the fixed parameter support vector regression. And this is the penalty parameter C, and all this they call it convex optimization problem. And the last regression function of the non-separateness E epsilon support vector regression and the load vector, it can be given this one f of x, which is can based on detected the high leverage point. This is the final regression problem, and this is the load vector. And another ones, it's very important. Another important tools in the support vector regression, we call it the kernel function. Kernel function, it's this tool can transfer from the non-linear space to the linear space. So fixed parameter is going to employ the RBF, residual base function kernel. So and the RBF kernel function can be given in this formula. And according to the Dehaan and Habshan 2018, the outlier can be based on the variable zi, which is nothing but is the last regression function, as we mentioned before. And this is the cutoff point based on the kernel function RBF. This cutoff point which can be separated between the outlier and the majority of the data. So now in the proposed method, which is called NU support vector regression, address the limitation of the epsilon support vector regression method, in which it can detect all mild outliers and the added the contaminations and the high dimensional data without showing masking and swamping effect. And the outlier and high leverage point can be detected by using following equation. This is the loose function. We call it NU tube because here the NU parameter which is can control to the epsilon tube. So we call it E tube, NU tube. So similarly, this is the convex optimization problem for the NU, the new class of the support vector regression, which is called NU support vector regression, and we can see the NU parameter here in the convex optimization problem, and also the convex quadratic given in this formula, and also finally the last regression function NU support vector, and also the load vector can be given on this formula. In our proposed method, we're going to use Basel kernel function, which is called Basel kernel of first kind, which is given according to this formula, and to separate it, the outlier from the majority of the data, from the normal data. We're going to use this cutoff point based on the Basel kernel and based on the median absolute deviation, and the median absolute deviation which it can be given according to this formula. In this approach, involving to detect all outlier points in the single iteration, and the computation cost would be less than those the iteration techniques. In the experimental result section, the Basel kernel function, it analyzes using the predict values to detect the outlier and high leverage points. So now we're going to test both methods in the real and simulation study. So in the first, we have this table. We simulated 200 explanatory variables with different percentage of the contamination. We have from the 5%, 10, 50, and 20% of the contamination, and also with different sample size. And we compare the correct detection of the high leverage point, and also we test the problem of the masking and swamping for both methods. And we can see here very clearly our proposed method have a high percentage of the detection and very less percentage of the masking and swamping effect. In the second test for both methods, we are generated the artificial data when exponential variables equal 50 and sample size is 20, and we replace 3 good observation as a high leverage point. And we can see very clearly in the plot A and B, and the figure number 1, which is represent our proposed method, NU support vector regression, can detect the actual number of the high leverage points. And also, if we can see here, it's very clearly in the 3-dimensional plot, the distance between high leverage points and the normal And the normal data, it's very clear. So even for non-expert statistician, it's very clear this all these points, it's very different from the block of the data. And here the second figure, which is represent the fixed parameter support vector regression, we can see this method suffer from the swamping effect, as we can see in this point number 5 and 14, and also in the 3-dimension figure, we can see the distance between the high leverage point and all the data point is not clear. So this is may some difficulty to separateness. In this part, we're going to test also both method in real, extremely high dimensional data, which is called cardio or heart disease data. This data is contained more than 6,000 exponential variables with sample size equal to the 30. So the first figure, which is represent our proposed method and your support vector regression, and this data already there is 3 high leverage points in the data. So our proposed method, we can see very clearly can identify the actual number of the high leverage points, and also if we going to the 3-dimension block, we can see very clearly the distance between the high leverage point and the majority of the data, and this one is very clear for non-expert user. And the second test, this is for fixed parameter support vector regression, and we can see this method suffer from the swamping effect even in the real data, and also we can see in the 3-dimensional plot as the distance between the high leverage point and the normal data set is not very clear. The last test, we will compare both methods for the time consuming. So the first, when we have we test this in the different dimension, but still it's high dimensional data. So first, when the p equal 50, it's mean when exponential variable equal 50 and sample size 20, and here when exponential variables is a 3,000 and sample size is 100, and we can see very clearly our proposed method, which is represented in the blue line, have less time consuming than the fixed parameter, especially when we have extreme high dimension data. And this point is very important in the extreme high dimension data and also in the big data. This is really serious challenge. Because we have all method, it takes too much time. So the novelty is make and improve methods to take less time than the others. And the conclusion in this paper, we developed a new diagnosis method for detection high leverage point for high dimension data, and the new support vector regression more efficient than the fixed parameter support vector regression for identification high leverage point in high dimension data with less masking and swamping effect. And the new support vector regression has less computation running time than the fixed parameter support vector. And also another attractive feature of our proposed method, it can detect both in linear and non-linear model. This is some references I based on my research, and thank you for your attention.
Thank you very much, Abdullah, for the presentation. Thank you.
Thank you, bro.
Yeah, very good work indeed, especially in this kind of day and age where data is really very complex here. So once again, on behalf of the organizing committee, we welcome the participants who have just joined us. So if you have any questions, by all means, just type in the chat box. We will answer them at the end of the session. Yeah? So we have come to the last presenter, Muhammad Faris Fauzi from the University of Defense, National Defense University of Malaysia. His work is on, his topic today is modeling the statistical dependence of rainfall variables using Kopala, a case study of the Pahang Lake. So Hafiz, I shall hand over to you and we will unmute you in a while. So please open your camera as well. Just a second, yeah.
Hello, Assalamualaikum.
Salam, yes. So,
Sorry, I'm using a computer at my working place, so admin is not allowed for the camera on my computer.
okay, all
But
right.
can you please share your
Can you
slides?
just share your slides?
All right.
Or do you need us to assist you?
I already open. You can see.
Yes,
All right.
great, great. So the floor is yours, Faris.
Okay. Assalamualaikum and good afternoon to everyone. My name is Muhammad Faris Fauzi from University Pertahanan Nasional UPNM, and I'm presenting today my research project, the title Modeling the Statistical Dependence of Rainfall Variable using Kopula, a case study of Pahang State. So we'll go through the background. Flood disaster is one of the natural disasters that frequently hit the country apart from landslide, forest fire, oil spill, and others. Big flood occurrence can cause property damage and homelessness. In Malaysia, seasonal heavy continuous rain from October to March in 2014 caused flooding in eastern area. Generally, all states in Malaysia were hit by flood during the year 2014, including Pahang State as well. The phenomena of climate change also contribute to the uncertainty of flood event that can be classified as exceptional circumstances. Analysis of rainfall variable also has become more crucial since it allows the climate modeler to understand the pattern of precipitation that could cause the occurrence of flood. So the problem segment is the issue of flood in Malaysia is receiving increased researcher attention. Flood normally occur when some part of the country experience high level of precipitation for a lengthy period of time. Consequently, natural disaster protection plans, which have flood mitigation project, essential study of rainfall modeling due to urgent need of water resource management. As a result, statistical analysis of rainfall is especially important due to the unpredictable climatic condition prevailing in many parts of the world. So the research objective, the main objective of this research, discuss the role of Kopula in modeling the structure of dependency between two rainfall variable, which is duration and severity. In this research, data were obtained from the Department of Irrigation and Drainage at Ampang, Kuala Lumpur. And the type of data we use is historical, monthly rainfall data, and study area at Pahang, selected station in Pahang over a period 45 years from 1970 to 2014. So the research methodology, the first one is a standardization index. The SPI was first employed by Mackey in 1993 for defining and monitoring severe drought and flood condition. The SPI calculation for any area or region is based on the long-term precipitation data for a desired period. This long-term precipitation record is fitted to a gamma distribution with probability density function. So the parameter of gamma probability density function are estimate for each set of monthly rainfall data for each time scale of interest. We analyze for 3, 6, 24, and 48 months time scale. To calculate the SPI, at least 30 years continuous monthly precipitation data were needed. So this is a classification for the SPI value. If the number +1 and above indicate the wet condition, and the SPI value -1 and below indicate to the dry condition, and it become normal when the value SPI is between -0.99 to 0.99 positive. Okay, for the preliminary step, the data set is fitted from the 4 distribution. For distribution, namely gamma, variable, log normal, and exponential distribution to rainfall characteristic for the 3 stations in Pahang. For each station, the best fitted distribution of each rainfall is subsequently selected using the ISMy value. As you can see from the table, the lowest value is the ISMy value. From the table, the log normal distribution best is selected for best fitted for both characteristic for severity and duration. So the second methodology, a copula. A copula is a multivariate distribution function that link joint probability distribution to their one-dimensional marginal distribution. Copula is appeared for the first time by Mackey in 1993 and be able to measure dependence for heavy tail distribution. So if X and Y are the 2 variables, which is severity and duration, the distribution function represent as this one. And the UV and U and V is a copula. So for the result from the table 4, show the base model for the given station where best is defined as the largest log likelihood MLE value. As you can see, the entire ball is the best copula model for each station. The most appropriate model for describing for the dependency structure between the 2 variables, duration and severity of the rainfall, is from the copula Archimedean family, Frank. So the conclusion is to estimate the best fitted copula dependent parameter, the empirical study analyzed to provide statistical evidence in choosing which parameter estimation method that are more accurate and efficient for each station. And the log normal distribution was fitted to each characteristic using the AIC goodness of fit method, and the Frank copula was found to be the best copula estimate by maximum log likelihood. So the future of the behavior of the upper part of the distribution will be analyzed by comparing the upper tail dependence of the observed data with the upper tail dependence provided by each copula to select the copula that fit the data. That's all for me. Thank you.
Thank you very much, Faris. Quite an interesting presentation. Right, so ladies and gentlemen, we've come to the end of the 3 presentations. So we move on to the second part of this webinar series, in which this session I hand over to my co-host, Dr. Noli, where she will be doing 3 things. Yeah. Number 1, she will ask questions to the 3 presenters. And then number 2 is she will moderate the questions that I can see some in the chat box. And then the third one, she will in general sum up the presentations that has been given by all the 3 presenters. Yeah. So without further ado, I hand over to Dr. Noli.
Thank you so much, Prof. Yong. Hello, Mr. Abdullah, Ms. Hafiza, and also Mr. Faris. Okay. Now I would like to pose 2 questions to each of you, and you have 1 minute to answer. Okay. The first question will be
Hafiz, can you open up the share the slide?
The slides, yeah, the
Just
slides of the question. Okay. Now the first question will be to describe. Hold on for a second. Okay, describe the novelty of your work. Shall we let Ms. Hafiza first to answer this question? Can you please unmute the mic? Thank you.
Okay, thank you, Dr. Noli. So the novelty of this work, so we developed method to impute missing values, specifically for circular data. So as we know, usually when we conduct an experiment, we will get a list of data with missing values. And this list of missing values cannot be ignored since it will give inaccurate and biased analysis. So for circular variables, research regarding this issue has not much been explored when we compare to linear data. So we are interested to develop this method. And from the presentation previously and from the results, we can say that the methods of Bootstrap T perform well to impute the missing values for circular variables.
Okay, thank you so much, Ms. Hafiza. Can Mr. Abdullah give your thought on your novelty of your work? Yeah, please.
Okay, the novelty of my work, it's we have proposed a new method of identification of the high leverage points in high dimensional data, not only for the linear but also for the non-linear model. So also our proposed method, as we can see in my presentation, it's very successful to detect the actual number in high dimensional data, and also one of the very important something we can to deal with the high dimension and the big data is the time consuming. This is very important. This one is very important point, and as we can see in my proposed method, it take very less time than the fixed parameter support vector regression. The classical method, we know we cannot deal with the high dimension data, but what we propose one can deal. But mostly method can deal with the high dimension data. It suffers from the masking and swamping effect, and also the time consuming. And our proposed method, have very small percentage of the masking and swamping effects, and also as well as take very less time than the others.
Mr. Abdullah, there's so much novelty in your work. That's good. Okay, shall we move to Mr. Faris?
Okay.
Yeah.
Hello.
Yes, we can hear you.
With the use of copula, allow multi-dimensional distribution to be defined based on the marginal distribution being relatively heterogeneous and not necessarily belonging to the same family of distribution. And this will provide a more flexible approach to modeling multi-dimensional distribution. Thank you.
Oh, okay, thank you so much, everyone. Since we are in the midst of the answering about the novelty of your work, may I add a little bit on commenting on your presentations. I think it would be better if you can put in one slide that show your contribution and novelty of your work, and also list up all your presentation that you have done in conferences or articles that you have published, because I did that during my Viva, and it works in such a way that the examiners find it more confident in your work. So hence the Viva session was quite smooth in a way. So yeah, that is my comment on a little bit on your presentation slides. Yeah, everyone. So I hope that you can improve your slides. Yeah, inshallah. All right. We move to the second question. Okay. For the benefit of students who have just started their postgraduate studies, can you give one piece of advice that will be useful to them? Yeah. Probably we have a few participants here that have started their postgraduate journey. So can you please give one advice to them? Please, yeah, Hafiza, are you here?
Yes, yes. Okay, the very important things in PhD for me, I think, is manage time wisely, because everyone has different time management based on your status. Either you are single or married, either you have children or not. Okay, and please make sure you have a very good circle around you who can always motivate one another. Okay, please don't be alone during your journey, and keep on educate your family and your close friends of what you are doing and of what your PhD is all about.
Okay, thank you, Hafiza, for the advice. Can we move to Mr. Abdullah, please?
Okay, my advice for the students, especially for the beginning of the PhD student, is one should be clear with the direction of the research problem and the research objectives. Also, plan your study accordingly with the time frame and how to achieve the objectives and the sufficient time, and also effective time management. And lastly, but not least, must have good relationship with the supervisor, and always seeking hello whenever face and research problems. And also, I have another advice for the also student. Actually, the new student for the PhD must be focusing, especially the statistician student, must be focusing in the area that's really now recently very interesting. It's like the machine learning, deep learning, artificial intelligence, the pattern recognition, neural network, and etc. This area and all this area and inside there, so many algorithms are very, very, very important in this our time. And thank you.
Right. So what you are saying, Mr. Abdullah, we have to keep researching on the trending. Yeah. So now it's really popular on the machine learning. So probably we had the idea on to research on them. Yeah.
Yes, exactly.
Okay. Thank you so much, Mr. Abdullah. Can we move to Mr. Faris, please? Any advice, Mr. Faris?
I just want to add on just a little bit. Just make sure you like what you are doing and make sure you understand what you are doing. And good luck.
Short and sweet. Thank you so much, Mr. Faris. All right. So I suppose that I would just summarize what you have said just now. So to new students, make sure to have a close relationship with your supervisors. I think the support is really crucial, and also you need to have someone to rely on, per se your colleague, so that you can discuss with. Yeah, I think that is also important from my experience as well. And then what else? Yeah.
I would just like to add what all the three of you have pointed out are very important points. I think the time management extremely important.
Yes,
the time management.
Yeah, exactly.
And Abdullah mentioned that do something that you like. Yes, this is something that students sometimes tend to overlook when they took up a research work. It's very much the passion of the supervisor as opposed to the student. So there has to be some interest in what you're doing. Yeah, right. Okay, so Noli, you would like to take care of the questions that is being raised in the chat box.
Yeah. Okay. So we have a few questions on the chat box. Thank you to Prof. Hafsa Hamidi. So the question is, does the proposed method of imputation is good only for good clean data? I suppose this is referred to Ms. Hafiza's presentation. And also the proposed imputation method is good, but as we know, bootstrap method is very intensive time, especially in the simulation study. Suggest to compare computational running time and also how to handle outliers. I think this goes to Ms. Hafiza as well.
Okay. So far, for the imputation method, we only propose only for a good clean data. Okay, so thank you to Prof. Hafsa. Maybe we can work for our future work regarding this matter. And cannot be denied that the bootstrap T method to impute the missing values using bootstrap T, we are facing the time constraint. Okay, so for the simulation study, I did for 5 months for the simulation study. But for the illustrative example, it depends on your sample size. But for me, I can just finish up in a week for the illustrative examples. Okay. And for the outliers, again, we did not consider the outliers in the simulation. Okay, but it can be considered later on in future.
Right, that will be your work after you graduated, inshallah.
Inshallah.
Thank you so much, Prof. And also Hafiza. Okay.
So you had
Okay. So thank you so much. Good luck for your future endeavor, guys. Okay. So I'll pass back to Prof. Yong for our next closing ceremony, I suppose. Yeah.
Thank you very much, Dr. Noli. So once again, to all the participants, I would like to thank you for joining us this afternoon. thank you once again for staying with us until the very end. So before we end, please allow me to have Professor Ibrahim, the president of the Institute Statistics Malaysia, to say a few words here. So with that, Professor Ibrahim, the floor is yours.
Okay, thank you, Prof. Yong. Thank you also, Dr. Noli, the two main organizers of this program. I'm sorry because I cannot unmute my video, so you cannot see my face, but I believe you all can hear my voice. All right. Okay. So, ladies and gentlemen, on behalf of the Institute of Statistics Malaysia, I would like to thank all of you for your participation in our first ever webinar, right, for the postgraduate student. Right. I'm very grateful because we have about 26 plus 6, about 32 participation. Yeah, participation from from the members of the ISM, right? And also thank you to the support from the local university, UPM, UKM, and others, right? For sending the student to this seminar. And I believe this will be a regular activities of the Statistics Malaysia, ISMy. All right, and I look forward to see your continuous support for our this webinar activities, and also other activities that we plan and we are also trying to organize. For example, next week we have a workshop on robust statistics, and we have few others activities planned in the future. So thank you, and look forward to see your continued support to the Institute of Statistics Malaysia activities. Thank you once again to Prof. Yong and also Dr. Noli for your effort to organize this event. Thank you very much. Assalamualaikum.
Thank you very much, Professor Ibrahim, for joining us today. Before we let you go for lunch, again, once again, thank you to all the wonderful participants. I can see there's only one question, but I am very sure in the next series, there will be more questions coming in. And what we can do in the next series is that we will try to improve the sessions to make it more interactive. So please watch the space, So we're going to share with you the call out for the next webinar. That will be in just a second, while, okay. The next one will be in January. So please mark your calendar in January. Again, once again, we will have the sessions where we do get the postgraduate students to present their work. And so please watch this space, So once again, on behalf of the organizing committee, we thank you, everyone. So if you can, all the participants as well as the presenter, if you can open up your camera, we can have a quickly have a group photo before we finish off. For some who don't have, I totally understand. So if you could open and okay, you can take the print screen, Hafiz.
Sorry, Prof, but I think the host should be accept.
Yes, the host will accept. Hold on, just a second.
Yes, because you don't accept me.
Yeah, hold on.
Oh, really?
Yeah. It's like you unmute to gambar tu. Okay, just a second, Okay, just a second while we sort this out. Okay. Right. Okay, Prof. Ibrahim's picture is there. Hold on. Abdullah, hold on. I know Faris is not able to do it.
Okay.
Just a second. Abdullah's face will be appearing in a few seconds. Hold on. Abdullah is still not there. Hold on, Try a second time. Okay. I'm unfortunately.
Abdullah.
Okay, great. So we're gonna print screen. So with the count of 1, 2, 3, say cheese.
Cheese.
Okay, fantastic. So once again, thank you so much and have a good day. Bye-bye.
Bye, thank you.
Prof. Thank you.